Okay, today we're going to be repairing a cast iron head. You can see the crack there. Looks like it was over tightened at one point in time or possibly dropped. I'm not sure. But we're going to go over the steps to repairing cast iron head.
All right, guys. So, got my air hooked up, got my leather gloves, some safety glasses. Um, you definitely want to put some gloves on, preferably leather gloves. If you've got cut resistant ones, great. This thing spins really fast, and if you're putting pressure on that and slip off and get into your hand, it will. If it'll cut through this, it'll cut through you. So at least leather will give you one layer of safety. Glasses, super important. I've had metal removed out of my eye 7 times with safety glasses on, but the first time I don't wear them, it could be worse. So, I think the glasses have probably saved me from some really big damage. And actually, it's pretty similar. The tool they use to remove the metal out of your eye is pretty similar to this, except a lot smaller. So, what I'm going to do is I'm going to start by cleaning the surface up, and I'm going to try to let this carbide bit do the cutting. It doesn't take a ton of pressure, but I'm going to groove this crack out real well so that when we fill that with material, whether we try to weld it up with some 312 stainless or if we just go ahead and braze it up with some nickel or silicon bronze, either way, it's got a clean, nice surface to adhere to. And the more deposition we get, the more material we get in there, the stronger the repair is going to be. So let me try to get the camera zoomed in here and let you see what I'm doing. I like to use the edge of the carbide like this versus trying to go in like this. It tends to want to jump around more. And because you'll go out the tip of that really quick doing that. So, and again, I'm just letting this thing do the cutting. I'm barely putting any pressure on it at all. The crack also comes up into here. Like I said, that's what makes me think that maybe it was over tightened. Comes up into this bolt or the bolt hole release. We may need to come back in here with the carbide again once we get this welded or brazed. We may need to come up in here with a carbide again just to cut this relief back out so that the head bolt or stud, whatever he uses, doesn't catch on the lip of our repair. You can see, got it grooved out pretty well. I want about half the depth of the carbide. I think that should be plenty. Now I'm going to get a wire wheel and I'll clean all this paint off of here. Then we'll get to preheating. We're going to have to heat this thing up to like 300 degrees for it to have a chance of holding. So let's get a wire wheel on the case. I want to just inspect this a little bit and make sure that crack doesn't come down into the head surface. Sometimes if you change the angle of the part around a little bit, the light will kind of glint off of that crack. Looks like we've got it. So okay, now you can either choose to use a bottle torch, something like this, to heat up the affected area over here. What's going to happen is this is such a thick chunk of material, it's going to draw the heat away from the part that you're heating. So what I'm going to do is I'm going to go ahead and put it in my powder coating oven. I'm going to set the oven at 300 degrees. Put it in the oven for probably, I don't know, it shouldn't take but maybe 45 minutes or so. I'll use my infrared temp gun to make sure the actual part is up to temp. We'll get it brought back over here and we'll go over making the repair. Okay. All right, guys, we're going to go over selecting, what cup we're going to use. If you're new to TIG welding, all of this stuff can be very, very overwhelming. The amount that you need to get started, right? Whether it's the amount of gas lenses and collets that you have, collet bodies and collets. Which do I use for which, process? Well, that all depends on what you prefer. A collet body and collet are old school technology. That's been around since the beginning of TIG, or what they used to call Healy arc. So the gas lens setup is kind of a newer deal. I mean, don't quote me on it, but I want to say they've been around for the last, 10 to 15 years at least. And it provides a lot better gas coverage. You can see with a collet body, these little holes are what your gas is flowing through. Your tungsten is going through the center of this. And then like this one is an adapter that Edge makes, which is pretty tits. And you can use one of their Pyrex or quartz cups with a collet body, which I prefer a collet body for aluminum, because every once in a while you'll get spatter back and it'll plug up that screen on the gas lens. So, and a gas lens tends to have a broader gas coverage area, which is good, which is good for steel and stainless and things like that. But on aluminum, you'll see a really wide path. That white frost, the cleaning action, you'll see a really wide path with a gas lens. And, it doesn't look the greatest, right? And so you see a lot of these guys that are, the best of the best, like Jesse McCollum, Mark Winchester, those guys, their welds are, absolutely perfect. And you don't see that broad white frost. They've got their machines dialed, right? And that comes into a lot of things: AC balance, frequency, your gas flow rate, all of that plays into it. And then obviously how wide of a cup you're using. So today, since we're running on that cast, I'm gonna run a 3/32 tungsten, a 3/32 gas lens. The way these Edge cups are set up, we're going to break it down to the bare bones here. Okay, we've got our torch with our back cap. This is a mid-length back cap. I want a 3/32 collet, 3/32 gas lens. Okay, so you can go ahead and drop that collet in there. Make sure you have your insulator, this white piece, flicked onto your torch. It's got a little lip there. All right, and then Edge also uses an additional thermal barrier, keep the heat out of the glass. So you back off your back cap until you can screw in your gas lens until it's touching, okay? in the beginning, I remember I had a problem. I was like, why the hell is this not shielding? Why am I getting air? Well, it was because I had my back cap tightened up first, and my gas lens, I can show you real quick. Tighten up your back cap, and your gas lens will not seat all the way. There's a gap, so you're going to be sucking in air. You definitely don't want that. So we're going to tighten down our gas lens until it's snug against that insulator. Okay. Now we can put on our additional thermal barrier or insulator, whatever you want to call it. And then this is their adapter for the glass cup. And I forgot to put my collet in there, so go ahead and take the back cap off and slide the collet over your tungsten. Oh wait, no I didn't. I've got it in there. Now to select which cup to use. On cast, I generally try to use a little larger opening. I go to this one. This one is a number 10. So this is a GL10S from Edge. And this is a Pyrex, not quartz. You got to make sure you have the proper diffuser in there as well. That's can be a little confusing as well, but these diffusers are made for different diameter tungsten, so you want to make sure that you've got the correct one. I had Stacia over at Edge. She sent me quite a few, so because I mean, it's gonna happen. You're gonna have some spatter come back at you if you dip your tungsten. You're gonna, you know, if your tungsten is touching the edge of this diffuser, if it's not put in the cup straight, and you touch your material and arc out, it's gonna weld your tungsten to your diffuser. So you want to make sure you have a 3/32 diffuser. And then they sell these handy dandy little tools. So I'm just going to get it started in there. You can see if you try to push it in by hand, it'll go kind of crooked. But they sell these little 3D printed tools, so you can push your diffuser up in there. Now, I'm just going to lube up the inside of that glass real quick and twist and push. And then with a cup this size, you could run quite a bit of stick out if you wanted to, but I'm just going to run about, I don't know, 1/4 inch stick out. Okay, so we've got that selected. Again, for aluminum, I try to go as small an opening as possible just to keep that cleaning action nice and small. And make sure you turn down your gas flow with that, because you actually can have too high a gas flow and it'll create turbulence and it'll try to blow your arc out. So, you know, those smaller cups, the 4s and 5s, you're probably going to only be at like 15 CFH, right? With something like this, you're probably going to be closer to 35, and, you know, something this size, you're probably going to be at 45. It's just kind of, you're going to have to play with your material and see, you know, if you're welding on stainless and you know you've got your heat correct and everything's nice and shielded and colorless, and then as this cup passes the material, it's starting to turn rainbow reds and blues, you know that, you know, you could probably back out of your heat a little bit and you need some more gas flow. Okay. So yeah, that's just a little tidbit on selecting the proper cup. You know, this is like, these are old school, but they work. They're good for field use so that you don't drop and break your nice fancy ones. There are a lot of different styles, but these basic Ceramica ones, I'll show you here. One is for a collet body. So these are good for aluminum. You run your collet body in there and then your collet. And then this style is made for a gas lens. So your gas lens screws right in there. and yeah, that's just older technology. They worked fine, but on stainless and titanium, things like that, where you need more gas coverage, that's where these edge products really shine. And they're proven. I mean, AC current, for when you're welding aluminum, it creates so much heat that you would think this glass would just shatter, and I'm sure you could. If you put enough heat into the Pyrex ones, they could break. But that's why they sell the quartz cups. They are rated for a higher temperature, and I've welded for hours on aluminum with their quartz cups with no issues at all. So my head should be getting close to temperature. I'm gonna go check the temperature. We'll get it brought over here and get to work. All right, you can see this bad boy is hot as hell, starting to cook off all that oil. What I've got here is ceramic wool, it's called. It is used in refractories and boilers. I use it for my forge, and I like to keep extra pieces of it. You can buy this stuff online everywhere. It's called ceramic wool, or rock wool is the name brand of it. And it's nice because it's a thermal barrier. That stuff holds up to a couple thousand. I want to say like this thickness is like 6,000 degrees or something. But this will keep the heat in the material for us. We've got our portion that we're going to be welding on here. So I'm going to get this thing set the way I want it. Again, it's hot as hell. So, and I've got my turntable on here. I'm not making it the easiest. So there we go. This is the portion we're going to be welding. I'm going to try to get an arc shot for you guys. We'll see if we can. All right, so I want to be sure to wipe this with a little acetone. Got this rag wet with some acetone because when we heat that thing, any oil that was in that crack is going to come seeping out of it, which will not leave you the greatest weld. So again, I told you I was going to try 312 first, 312 stainless. It tends to work really well with cast iron. So let's see how it goes. Get a good ground. Oh yeah, that's pretty nasty cast. So I'm going to try not to block you guys. I'm standing in a goofy position, so this should be fun. Having a hard time getting in here without blocking you. So I'm not giving it a ton of heat, because you'll notice on cast it's very porous. You may get some porosity in it, and what you want to do is just keep adding some good material to it, okay? Kind of having a hard time dipping my rod because of the position I was standing in to be able to show you guys. I'm going to come up here and make sure we've got plenty of material up here. I'm trying not to cut away this edge where the head bolt or head stud is going to seat. Okay, so you can see there, I had pretty good gas coverage on that with that edge cup. What I need to do now is get it covered up, because that we do not want this thing cooling quickly, okay? So we want to get that wrapped up. I've got an old jacket that, oh, let me zoom out here so you guys can see. I've got an old jacket that I'll grab, and we'll wrap it in that as well. The old nasty Carhartt. So this stuff's like fiberglass, so I mean, you definitely don't want to put your good jacket over it. Got that ceramic wool and a couple of layers material on top of that. This thing wrapped up nice. Okay, so just to recap, we had a cast iron small block Chevy head that was cracked, either over tightened or whatever, what have you. It was cracked, so we went ahead and used our 1/8 inch microcarbide, or pencil grinder they call them, our pencil die grinder. Got it grooved out, went ahead and heated it up to 300, pulled it out of the oven, got the ceramic wool put on it just temporarily while we welded up to keep that heat in there. We wanted to go ahead and weld it up with some 312. I was going to try that and see how it went. Cast iron is really porous, you know, and that's why brazing works so well for it, right? I've got probably 5 different rods that I will go through depending on the quality of the cast. I've got an Easy TIG rod that is supposed to be made for cast, and it doesn't require preheating, but I've only had that work well one time. I've got my 312 stainless that I use for if I were to weld it up, right? You could try 309. 309 is good for dissimilar metals. Say you're welding mild steel to cast, or stainless steel to mild steel. You would use a 309 filler rod for that. With cast iron, you want high nickel is what you want. So if I were going to braze it, I would use 99% nickel. You could use silicon bronze, right? All of those rods are a DC rod, DC negative rod. You could use Aluma bronze, and that one you're going to run AC current like you would be welding aluminum, and those ones are strictly, those last 3 are strictly for brazing. That's where we're going to flash over and melt the filler over the crack, and we're not actually penetrating into the parent material. It's just adhering on the surface, and it uses surface tension to hold that crack closed, almost like stitches or something on a wound. We used our Everlast 255 EXT. I've had that thing 5 years now, and it's a workhorse, amazing machine. They just had a new 500 come out. I want it just because it's big. Use that. We used our Edge welding cups, number 10 Pyrex cup, and again, they just are phenomenal. Get a hold of Stacia over there, Stacia and Eric. They'll get you taken care of. If you have any questions, they have over 200 styles of TIG cup, and every single one of those Pyrex cups is blown by hand by the guys in the shop, her husband and her sons. Family owned, everything's American sourced, American made. If you have any questions on their website, you're confused as to what you need to buy with your cups, say you go and buy a cup and you get it in and you realize it came with a 1/16 diameter diffuser because you didn't think to ask for a 3/32 or an 1/8 inch diffuser, then she'll get you taken care of. I would rather call and let them know what size torch you're running. Are you running a number 9 or a number 20? Are you running a 17? whatever you're running, they'll get you set up, and just let them know what you do a lot of, okay? If you do a lot of aluminum, a lot of steel, what amperages you're running, and again, what torque size you're running. Thanks again for watching, guys. I know my videos tend to be a little long, but there's just so much that goes into welding, so much information that I feel like if you hear one thing that helps you, then you've learned something today, and my video served its purpose. You can feel free to contact me, Facebook Messenger, Instagram, whatever. It's at Juggernaut Weld Fab. Go follow us on those. TikTok. Keep watching our videos. Please hit the subscribe button. We really appreciate you guys. Have a good day.